Well, hey class, this video is going to look a little bit different today because we're just going to be punching buttons on a calculator. I'm going to show you how to graph systems of equations on a TI-84 calculator, and I'm going to be following the note-taking guide. So the first thing to know, technology is going to be helpful if you have functions with really big numbers that won't fit on a small graph, or if the intersection is in between grid marks. These notes are for an 84 calculator, but if you have a TI-83 or something else, it should be pretty similar for any graphing calculator. This is an important tool for the ACT and for college math classes. Most of them will let you use this calculator right here. This is a school edition, so I've got some colors on mine that you might not have on yours, but they should work the same. So the first thing you're going to want to do is solve your equation for y so that they are in y equals mx plus b form. And I'll put my note-taking guide right here. So they need to be in y equals mx plus b form. At the top left of your calculator, you're going to press y equals. And it'll take you to this page right here where you can have all your different equations and enter your two equations under y1 and y2. Now, if you have equations under y3 and y4, you might want to clear those out and just graph the functions that are in your system there. So just have your equations in y1 and y2. If your slope is a fraction, I recommend keeping it in parentheses. In front of x. The reason we do this is to actually get the fraction in the calculator correctly. There is a mode in here where you can add a fraction, but I think it's just as easy to put them in parentheses. To insert x, you're going to hit this button right here with the x, t, theta, n. It's to the right of the green alpha button. You'll hit graph. It'll pull up a couple graphs on here. And then if you need to adjust your window to get the intersecting point, you can hit window, and it'll bring you to this screen right here. Now what this window button does is it shows the lowest x value and the highest x value, and you can kind of adjust those accordingly. It'll also show you the minimum and maximum y value. So you can see if the graph were up here somewhere, or if the intersection point is going to be up here, you would need to make the y max bigger. The scale on x and y, I like leaving those at 1. Delta x doesn't really matter. So that's kind of how you change your window. If you hit second trace, then it's going to have a list here for you to find different things on your graph. We're going to be looking for the intersection, so we're going to go down to 5, which is the intersect, and hit enter. Now, I don't have any graphs in here, so you can't really do it yet. You'll hit enter for y1, enter for y2, move the cursor to where the intersection is, and hit enter again. At the bottom of the calculator, it'll give you an x equals and a y equals, and that's your ordered pair. Let's do the examples together. So example 1, let's go back to y equals, and follow along with me. 4x minus 3, and then in y2, we'll type in negative 2x plus 5. So the negative is down here at the bottom of the calculator. Use this for your negative. That's a subtraction sign. Your calculator will get confused. Use this for your negative. So we'll type in a negative 2x plus 5, and then we'll hit graph. You see this one is color-coded, which is going to be pretty nice to tell the different functions, and we see our intersecting point right there, so we don't have to worry about changing our scale of our graph. We don't have to change the window. From here, we'll hit second trace, we'll go to intersect, and like I said, it'll say y1 or first curve. So we are on the first curve, we can hit enter. It'll say second curve. You see the cursor hopped up to the second line. We'll hit enter again. Then move it towards the intersection point, make a guess, and hit enter a third time. And so my intersection point here is at 1.33333 and 2.33333. We should know that that is 1 1/3. Excuse me, 1 1/3, comma 2 1/3. And that's where our graphs intersect. On number 2, we've got one with a fraction. So to clear this one out, we're just going to go back to our y equals and hit clear on those two equations. We'll put these in parentheses, 3 over 2. And to make a fraction, you just use the division sign there, 3 over 2. Close that, x plus 7. And then y equals negative 5. Remember to use the negative sign. And then subtract 2. Whoops, 5x minus 2. We'll hit graph, and we'll see where these intersect. So we don't need to change the window. So we can go second, trace, intersect. First curve is on blue, second curve is on red, that's fine. And then guess you'll have to use the left and right arrow keys to get there. There's a pretty good guess, and it gives you this funky fraction for your intersection point. So we're just gonna write that in. We'll round it off at some point there, but we'll just write that fraction in, negative 1.3846, comma, 4.9231. We'll leave 4 decimals on each one. All right. Our third system, we'll go back to y equals, we'll clear them out. Negative x minus 8, and we'll do in parentheses 1/4 x plus 5. We'll graph those, see where our intersection is, and you can see our intersection is barely off the graph over here. You can still do it without changing the window, but let's change the window just to make sure. Now, we needed to go that way to the left in the x-axis, so I'm going to make the x minimum, how about negative 20? We see how that changes the graph. And we've got all these, negative 10 to negative 20 over here added to the graph. But we can see the intersection in there nicely. Let's hit second trace, go down to intersect, hit enter. First curve, second curve, enter, enter. And then we'll move to the guesstimation spot and hit enter one more time. We get a nice answer there of negative 10.4, comma, 2.4. If you want to turn those into fractions, that's fine. I'm happy if you leave them as decimals, though. Move my paper. And last but not least, let's do this last one together. 3/5, keep it in parentheses, 3/5, x plus 1, and y equals 12. So it's graphing the first line, and it's thinking, and it's thinking, and it's thinking, and it stopped spinning up here. So that means it has graphed the second line, but it didn't show up. Now, if we think about this equation, y equals 12, that means y is 12 up here on the graph, and it's going to be a horizontal line straight across. But it's not on the graph, so I'm going to go to my window and I'm going to go back to negative 10 for my low x value, and I'm going to let the x minimum stay at negative 10 and change the x max to 20. I only need to go up to 12, but I like giving a little extra space on these graphs. Now here we see both lines, but again we see the intersection is going to be way out here on the x-axis. So let's go to window. Let's change our x max to something that's pretty big. I'll put it up to 30, I think. No, I think I put it at 3 instead. Yeah, sorry about that. Let's make it 30. Now let's try graphing them. So now we're going to get the intersection point. So now let's go second trace, down to intersect, enter, enter, enter. 18.333, that's 18 1/3, comma, 12. Guys, that's how you use a TI-84 calculator to find intersection points. Thanks for watching this video.